Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of slope and y-intercept. This is standard 8.4C in the great state of Texas, and we are using item number 39 of the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So Emily is selling greeting cards. We have a linear relationship here between the number of boxes she sells and her profit. That makes sense. The more boxes you sell, the higher the profit. So you have an increasing graph right there. And so it just asks us to describe the profit. And it seems like we're wondering, how do we find that on this graph? Well, let's see if we can figure out what this profit is on this graph. So if she sells one box, she gets a little bit less than $10. 2 boxes get you about 15-ish. 3 gets you a little bit more than 20. You notice how at each point right here we're increasing. So that's what that line is doing for us, is it's increasing for us. And so really what we're asking for is, what is that rate of increase? Profit. They asked for profit, but really what we're looking for in this particular problem, we're looking for the slope. We want to see how much that line increases. And that same profit, that same price that she gets for every single box is going to increase with the number of boxes that she sells. Her profit is going to increase, but it's going to stay steady. So that's why we can calculate that as our slope. So we would normally think of, well, y equals mx plus b, right? That's our slope-intercept form. But you notice we don't need the plus b. Look, it goes through the origin. So it is a proportional relationship. And so what we're going to use is we are going to use direct variation. And so it's basically, it's going to look and function the same way. We're just going to not really worry about that y-intercept because it's 0, so we're just going to look at that slope, and we're just going to look at that with a k rather than an m, just to differentiate the two. But really it's going to be that same thing, right? Slope, whether you're looking at the slope-intercept form, whether you're looking at direct variation, slope is going to always be calculated as your rise over run, so that's your change in y over your change in x. So this means we need to find 2 y coordinates, subtract them, that's going to be our numerator. We need to subtract 2 different x coordinates that match up with those 2 different y coordinates, that is our denominator. So whenever you can, make it easier and take a look at this. Since it does go through the origin, I'm going to use this origin as one of my 2 sets of coordinates, because subtracting 0 is easy, like you just don't do anything. We do need to find that other set and take a look. You notice that I said this is, when I was describing this, I gave you estimates like less than 10, maybe 2 has got 15-ish, greater than 20. Really right here where it's got 4, that's the only spot that I see that looks like it's actually passing right through an integer right there. So I'm going to use that, because above you got 5 gets you 38-ish, 42-ish. We don't want ishes. That's not going to help. We want actual numbers. So let's take our y coordinates, right? So that's going to be 30 minus 0, which obviously is just 30. And then 4 minus 0, which obviously is just 4. So that's a great thing about using the origin. You can just take an x, y coordinate, put the y on top, and you have your slope. If you get 30 over 4, so that is going to be, there we go, 750. So that's where I was getting that. So that 15-ish right here for 2 actually is 15, because 2 times 750 is going to give you 15. So we were close. So our answer here is going to be A. So the profit, remember, equals our slope. So she sold them for, got a profit of $7.50 per box.